I'm Gary Griggs, and I'm a professor of earth sciences at the University of California, Santa Cruz, and I study coasts, which include beaches and sand, coastal erosion, coastal protection, and sea level rise, and how that's affecting us and what our options are for responding or adapting to that. Sea level rise just refers to the level of the oceans, and that changes as the planet warms. So as the Earth gets warmer, two things happen. Seawater expands and ice melts. And if we were to melt the remaining ice on the planet, which is in continental glaciers, in Greenland and in Antarctica, we could raise sea level about 216 feet, plus or minus a few inches. That would impact probably several billion people around the planet. Right now, there's 635 million people living within 30 feet of sea level. No scientist thinks that's going to happen in this century or the next, but we don't need it all to melt to create major problems for coastlines around the world. Even 3 to 5 feet of sea level rise is going to create some amazing, should say, incredible damage to coastal cities and coastal populations. Well, there are dozens of cities along the coast of the US that are vulnerable to sea level rise. Most of those are along the Atlantic coast and the Gulf States coast, because they're very low lying, very low relief. And that includes Washington, D.C., Annapolis, Atlantic City, Miami, Baltimore, Philadelphia, Charleston, Ocean City, Boston, to name a few, and they are already experiencing what we call sunny day flooding. Even during calm days, sea level is now moving into those cities. And as sea level continues to rise, it will occur more often, last longer, and extend further inland. On the West Coast, we have a different geology so that most of our cities are higher, not all of them. So we will not experience those same effects as soon. In the long run, we will. We've used seawalls and rock revetments for decades to protect coastal communities, both private property and public infrastructure. And some of these, well-engineered, well-built, have lasted for 90 years, and some haven't lasted for 90 days, depending on how they're built and where they're built. If we look around, we find that there's some impacts to those seawalls and revetments. Among the most important is what we call passive erosion. So on a shoreline that's natural, that's unprotected, as sea level rise, the coastline and the beach would just continue to move inland. But once we put a solid barrier there, a seawall, and sea level continues to rise, we will flood or drown that beach. So we're not going to have a beach in the future. We're going to be protecting private property at the expense of a public beach. And all protection ends somewhere, whether it's a dam or a levee or a seawall. At some point, it will be overtopped, or we will get a worse condition than we had planned for. So they can provide short to intermediate term protection, but at some point they're going to be overtopped. And I think we should think about these as essentially short-term, very large Band-Aids. We have now, or the Corps of Engineers has now proposed a number of very large walls around some East Coast, Gulf Coast cities, including Charleston, Miami, Galveston, even New York and New Jersey. These are very expensive. We're talking about billions of dollars, $50,000 to over $1 million per linear foot. So I think cities need to ask, how long will these be effective? Who's going to pay for them? What are their impacts? And who or which neighborhoods are protected and which get left out, which raises a really important question about social equity. Responses to rising seas are really pretty limited. Doing nothing or denial isn't going to work for long. We spent a huge amount of money along the Atlantic and the Gulf Coast nourishing beaches or adding more sand, something like $12.4 billion in adjusted costs, which has added about 1.4 billion cubic yards of sand. And that's a hard volume to imagine, but it's about 140 million dump truck loads. It's proven to be a short-term solution, and almost every place we've done it, it requires repeat nourishment. There are some places in Florida where we've nourished the same beach 18 times, which says something about, how long it survives. It's important to keep in mind that over the long run, there is nothing we can do to hold back the Atlantic Ocean or the Pacific Ocean. While it's not at all popular, at some future time, we're going to have to move inland. We're going to have to relocate away from the shoreline, whether we call this managed retreat or unmanaged retreat. It will eventually occur. And there are a number of places where that's already happening. It's happening on places on the California coast, publicly. Rodanthe in North Carolina is a place where there's been a lot of publicity recently. Hawaii. So remember, we have 216 feet of potential sea level rise to deal with. So we cannot hold back the oceans forever. I think it's important to keep in mind that while sea level rise is an important process that's going to go on for centuries, and it's rising now at an accelerating rate. Over the short term, probably at least till mid-century, it's going to be these short-term events, short-term extreme events that are going to cause the most damage. Thinking about hurricanes like Katrina and Sandy and Harvey and Ian, and on the West Coast, El Niños and large waves arriving at times of high tides, as we saw in January of this year. These are going to be more damaging over the short term, but they're going to be riding on top of sea level rise. So the higher sea level rises, the further these extreme events will extend inland and the deeper the water will be. The rate of sea level rise is not the same everywhere. While sea level is rising for the global oceans, because of land motion, it's going to be different in different locations. So in New Orleans, for example, or Venice, the land is actually sinking. So sea level is rising relative to the land 3 or 4 times faster than the global sea level. And then there's places like Alaska or Scandinavia or even parts of Northern California where the land is rising. So sea level is rising much more slowly. In fact, it may even be a negative rate because the land is rising faster than sea level is. There's really only one thing we can do that's going to have a big difference over the long term. As long as the planet continues to warm, we're going to melt ice and expand ocean water. So the more fossil fuels we burn, coal, oil, and gas, the more greenhouse gases, particularly carbon dioxide, we put into the atmosphere, which is going to warm the planet and increase sea level. So the only way we can slow this down and eventually stop it is to do everything we can as fast as we can to reduce and then eliminate our dependence on fossil fuels and move to renewables. So today in the US, about 77% of all of our total energy is provided by oil, gas, and coal. Although good news, last year for the first time in terms of generating electricity, renewables provided more than coal. So we're making progress. We still have a long ways to go, but we're making progress. This is what I call aggressive incrementalism. We just need to be even more aggressive.